All right. Our final broker talk is going to be by a person, again, who's come thousands of miles away, Guillermo Cabrera-Vives on the AleRCE broker.
All right. Hello, everyone. Thanks, Nancy. Thanks, everyone, for having me here. My first question is, how many of you have accessed CDF data through AleRCE? Can you raise your hand? Okay, great. So most of you know what I'm going to talk about. How many of you have accessed LSST data through AleRCE? Okay, a few of you. All right, so today I'm going to talk about AleRCE. So most of you already know what this is. So I'm going to do a brief introduction to what AleRCE is in CDF data, and then I'm going to talk about what has happened with Rubin data. So first of all, you all know this for sure, but the ecosystem of brokers works like this. You have survey telescopes, then the alert streams go into the community brokers, and then the data goes into the downstream brokers and TOMs and to follow-up resources or the user community. AleRCE is one of these brokers that originally had these 4 questions and 4 scientific questions: transients, active galactic nuclei, variable stars, and solar system objects. So we're not very strong on solar system objects, but I always put that in my slides in case someone wants to jump in and say, I can help you with that, okay? But we think that our strength lies in transients, AGN, and variable stars. So what type of tools we have in AleRCE? Well, most of you must know the Supernova Hunter. So the Supernova Hunter is what we use every night to report supernovae from CDF to TNS. And basically, it's an interface that astronomers use to find supernovae in real time, right? So every morning, 1 or 2 astronomers, or 3 or 4 or 5, connect to this system, and they basically see what's behind that and report supernovae to TNS. And that has made us the 3rd group reporting more supernovae to TNS after CDF and PAN stars. Okay, and we have a purity over 99% in what we report. This is like another one of our interfaces, our web interfaces. This is the AleRCE Explorer. So the Supernova Hunter works on like 1 alert at a time, right? This works on light curves. So basically, it's a way of exploring all the data that's behind AleRCE from a web interface. And so as you can see, you can choose different types of objects that you want to find, let's say AGN, microlenses, TDEs, supernova type 1A, whatever. And then you have a list of them, and then you can explore them. You can look at the light curves. You can look at the image stamps. You can, so there's cross-match against other catalogs. So there's a whole bunch of things that you can do with them. And of course, we have a watch list service in which you upload a set of coordinates. And whenever something happens, something appears at those coordinates within some radius, then you get a notification. So behind AleRCE, we have a lot of machine learning models. I'm going to talk about a few of them, which are what I think the most popular ones. So for the Supernova Hunter, we have a stump-based classifier, which is basically a convolutional neural network. And it classifies every stamp from CDF into AGN, supernova, variable stars, asteroids, or bogus. And this is the confusion matrix for that particular model. And this is what's behind the Supernova Hunter, okay? We also calculate for CDF around 185 features for the light curves. And for Rubin, it's over 400. I don't know the exact number, but it's over 400 features that we calculate. And you have access to those features directly through our database. I'm going to tell you a bit more about that in a few slides. And behind the scenes, there's a balanced hierarchical random forest that performs classification. We have 2 taxonomies. So we have the light curve classifier version 1, which is like the old one, and the new one, which is the light curve classifier version 2. The first one has, so the second one has a more detailed taxonomy, but the more important thing of it is that it works with force photometry data. So basically we have 2 light curve classifiers, one that works only on the alerts and the other one that works with the force photometry data. And so if you go to the Explorer, you can choose the classifier you're using. And you can see that there's like the light curve classifier, the light curve classifier top, and the balanced hierarchical random forest force photometry. And that's the one that works with a more detailed taxonomy. We have the stamp classifier, and you can see that there are other 2 things here, right? And those have a beta tag, which means that we would really love to know what you think about those. So we're not completely sure that those are doing exactly what they're supposed to do, but we have heard that for microlensing events, the beta classifier is better. And we have heard this from the microlensing community. And that's a transformer model. So it's being still tested. And so what kind of user interfaces we have for our data? Well, the web interfaces that I already showed, Jupyter notebooks. So we have a bunch of Jupyter notebooks that show you how to use our client that connects to the APIs. So we have an API, you can access directly the data through the API, or you can use our client. For CDF, we also provide you direct access to our database. And we also have, so the output stream goes into the, it's part, so AleRCE is part of the TOM toolkit currently. But now Rubin is here, right? So you all know this, hopefully. You do, right? All right, good. And so we've been working during the last year, I would say, really hard on Rubin data. So what's user interfaces work for Rubin right now? So we don't have the Supernova Hunter currently available for Rubin data. I'm going to talk a bit more about that later, but we have the Light Curve Explorer. The AleRCE Explorer. We have the client, we have the API, so you can access the LSST data, the alerts data from Rubin directly through our API or through our client. We provide you access to the database through a tab service. And so in principle, we could stream the data, but under request, okay? So we haven't tried anything fancy like that. So this is a plot I created yesterday, which shows the number of alerts per night that we received from Rubin, okay? So we started working on a commissioning phase with Rubin in September. And we went public on February 24. So you can see here, so 24, 25th. So this is where we went public, right? And you can see that before that, we were getting around 100,000 of alerts per night. But a couple of days before going public, we started receiving millions of alerts, okay? And so you can think like, why, how this happened, right? And basically, there was some changes in the pipeline, in the Rubin alert processing pipeline, and they kind of switched the reliability score. So we started receiving more alerts, and that were different from the ones we previously had. So Rubin, so let's say this is data from the light curve of from CDF. And in Rubin, you find something like this, okay? So you can see that here, there are a lot of alerts the same night, okay? So if you go to AleRCE and look for data on Rubin, you'll see something like this or something like that, right? So you've seen maybe on the previous slide, on the previous presentation, something like that, right? Where you have a lot of alerts on the same night, right? So these were deep drilling fields that produce a lot of alerts. per night. But if you're careful and you dedicate some time, you can find something like this or something like what other brokers have shown, where you see like a really nice light curve. So we trained a stamp classifier previous to the public release. Okay, so if you go to AleRCE right now, you get access to the probabilities from the stamp classifier, and this was our confusion matrix for the stamp classifier before going public. And on the right-hand side here, you can see on the x-axis the rejection rate, okay, and on the y-axis the precision. Oh, that's in Spanish, metric. It should be metric. Okay, this was done by a student. If it's wrong, it was a student. So basically, what you can see here is that after a probability threshold of around 75%, we got almost perfect. Okay, this is in terms of precision. So most of the things you were getting were real supernova after a 75% probability score. And so but what happened was that when we started getting this million of alerts, we started noticing that we got a lot of this kind of things, right? So and those were classified as supernova by the stamp classifier. And so we realized that there was something going on here, and we've been in contact with Rubin constantly trying to figure out what's happening. And this is a plot that Francisco Forster created, and basically said, I'm going to grab all the supernovas that were classified during that period of time, and I'm going to, by eye, select them and decide what I think they are. Okay. So you can see that there's a bunch of supernova here, right? But there are lots of cosmic rays, okay? And in blue, you have the ones that do not have the pixel flag cosmic ray active, and in orange, the ones that do have that. And so the rest are all these kind of things over there, right? So I'm running out of time, but I'm telling you that this is a comparison chart between CDF and LSST. So the Explorer, the Supernova Hunter, the Watchlist, Python Client API. So right now we have the Explorer for LSST. We have the Supernova Hunter. We don't have the Supernova Hunter. We don't have the Watchlist for the LSST, but we do have access to the data through our Python client, through our APIs, through our TAP services, and we have a whole bunch of Jupyter notebooks that you can check there. So final words, AleRCE provides this huge ecosystem, not only for Rubin, but for multiple surveys. But in the case of Rubin, the alert stream is continuously evolving. So that means that we need to work really close with the Rubin team to make sure that all the brokers are doing what are expected to be doing. And so close communication between brokers is super important, and also between the surveys and the brokers. We are really good friends with all the brokers, okay? I want to say that because some people think we're enemies, but we're not, okay? We really love each other. And so as you may know, we're planning on ingesting Roman alerts. And so early coordination is super important for this to happen, to have something running in a year or two. And well, that's it. If you want to contact us, and you're part of the community forum, that's our link, and you can also send us a link. Thank you.
Questions for Guillermo? Gotham.
Yeah, great talk as usual. You showed the postage stamps from early Rubin data are in flux. They're not yet at the quality level, but the same is also true of the Rubin cadence that's currently being executed. How are you making things like 8080 or your feature-based classifiers cadence insensitive? Because we know that's going to change dramatically between not only DDF and wide fast deep, but between year 1 and year 2.
Okay, thank you for the question. So there's like the long answer that I can give you later, and the short answer that I'm going to give you now. Okay, So currently, we're not training the light curve classifiers for Rubin because of that. Okay, so we do have a trained version on simulated data, but it's not even worth our time to try and test it on real data because we don't have enough data to do so. But in terms of how the cadence affects everything, it does. And so we have done a lot of tests changing the cadences for different types of data and trying to figure out what are the best ways of addressing that particular problem. In particular, the transformers are very sensitive to the cadence, to the transformation in cadence, to the difference in cadence. But the random forest is not so it's not such a big impact for the random forest. And we had this test, I told Matthew this, when CDF decided to do some deep drilling fields without telling us. And, and so suddenly our models were like broken and we had no idea what was happening. And then we realized that there was some nights of deep drilling fields in the data.
All right, we're negative time. So let's thank Guillermo again.